Hey all, welcome back to my channel. So many of you are requesting me to explain this testbench architecture of system Verilog in deep. So there is no problem in explaining in deep about the testbench architecture. But the thing here is, you have to know first in order to know about the how you are going to write a code in the test bench for system Verilog. You have to know all the basics regarding this, how to write the test bench architecture. So that is why I'm not presently I'm not explaining about this test bench architecture in deep to you. But since many of you are requesting me to explain this testbench architecture in deep, so today I'm going to explain it basically like what is happening. Okay, along with this block diagram, I'm going to explain it with an example for you so that you will have an idea of how we are going to write a test bench code in it. But before going to this test bench architecture example, I'm just telling you, yeah, in order to write that test bench code, first you have to know the basics of system Verilog. You have to know everything about system Verilog before writing the code of the system Verilog. If you are aware of the system Verilog language, if you are aware of this course, then it is fine for you. But if you are not aware of the system Verilog course, okay, don't panic by seeing the code, or don't panic like how this much we have to write. I mean, is this the code that we really write when we enter into the verification field and all? Okay, so don't worry about that. So basically, once you know everything about system Verilog, then it is just a piece of cake for you to write the code or to check the to verify the design by using this thing. Okay, since you don't know about the system Verilog course completely, you may fear by seeing the code. But trust me, when you uh, listen to all the classes of this system Verilog, then writing a code is just a piece of code for you, because the main advantage in system Verilog as well as in universal verification methodology is almost 50%, 50 to 60% of the code that we will be writing in one particular design is same for all designs. That means we will be reusing. That is the main advantage in system Verilog. Okay, whatever code we will be writing for one thing, we will be reusing the same pattern for many other designs also. So if you remember this 50 to 60% of this pattern, then the remaining 40% is very easy for you. Okay, so don't worry about writing the code or learning the code. Okay, after completion of the testament sorry, after completion of the system Verilog course, I will definitely explain the code partwise clearly for you. But since many of you are requesting me to explain it with an example to explain more deeply about this test bench architecture, today I am going to explain this with in related to the code. Fine. Okay. So firstly, before going to the code, let us first discuss, let us just warm up like what is happening here, since I have already explained in the test bench architecture. If you didn't listen that, I'll link that in the description box, you can go check it out there. Okay, so actually what is happening here in test bench architecture, the transaction is nothing but it is the data, like transaction consists of all inputs and outputs packets of data, and this transaction is sent from generator to driver. Okay, and then from driver it is sent to DUT through interface. Is it or not? So from driver it is sent to DUT, and again in the DUT the logic is being done. The work it is whatever data, that means whatever packets of data that you are sending, that will be worked on the logic of the design and the test, and then again it will be sent to the monitor through the interface itself. So here the interface is nothing but it's a just like a bus. Okay, what will be the use of bus? Basically, in order to pack all the data in one form and it will be sending it. Instead of taking individually, we'll be packing all the thing in a format and we'll be sending it to the DUT. Actually, that is the use of interface here. Okay, so from interface it will be sent to the monitor. Here one more important thing is we can generate the test bench architecture. That means we can write the test bench with using monitor or without using monitor. So basically when you see the Verilog code, Verilog test bench code, you may see that like you will be using only display instead of using monitor. So basically what is the difference between dollar display and dollar monitor in Verilog? So dollar display means it will only used for displaying the values, that's it. But when it comes to dollar monitor also will display the values, but every time there is change in the value of the values that you are given in the monitor, it will every change will be monitored and it will be displayed automatically. But this doesn't happen in dollar display. That means dollar display is used just to display the values, but it doesn't monitor the values or monitor the changes in the variables that you are given inside the display. But when it comes to monitor, whatever variables that you are mentioning within the monitor, it will be displaying all the, it will be monitoring all the changes in that particular values. Okay, so basically, similarly, just like in Verilog test bench, you will be writing the code by using monitor, or you may write the code without using monitor also. Similarly, in system Verilog also, when you are designing the test bench architecture, you can write the code by using the monitor or without using the monitor also. Okay, so if you are using the monitor, then the values will be monitored continuously. If you are not using the monitor, the values, the changes in the values won't be displayed in the log file, that's it. Okay, and then from monitor again it will go to scoreboard. So this entire blocks will be enveloped inside the environment. Envelope means they will be capsuled inside the environment. That means they all will be placed within the environment. And again, this environment is again placed on the test. Okay, test means nothing but the test cases. For example, as I told you in the before itself, for example, if you are writing a memory, so in memory you will be taking various test cases, like in order to read the memory, in order to write the memory, or in order to read the memory by using these values. So these are different test cases. Okay, test cases is nothing but what is the case that you want to test. Okay, you will all be writing the test cases. All the test cases will be here, and then after the test you will be writing the test bench top. Okay, test bench top is nothing but it is used for instantiations purposes. That means in Verilog, if you see, you will be instantiating the Verilog test bench to design by using DUT instantiation. Is it or not? The same thing you will do here also. Every instantiation of these blocks like environment, generator, driver, all the instantiations will be placed within the test bench top itself. Clear? Yes. So this is about test bench architecture. Now let us see how we are going to design, or how we are going to write a code for this test bench in system Verilog. Okay. Right, have you seen this? So this is how you will be writing the code. Okay, first don't just listen to me. First don't listen to the code, don't see the code, listen to me first, and then you check the code. So what is the first thing? This is my test bench. Okay, this is the example of a simple adder. Okay, so this is my DUT. If you see this, this is the DUT. I hope it is visible for you. Okay, so this is my DUT. Okay, so where it is an adder, it is having two inputs A, B, and one output C, along with clock and reset signals, right? So this is all my adder contains. So as I told you, transaction is nothing but what are the inputs and outputs that your particular design contains. They all will be considered as transactions. So that is why transaction consists of all the inputs and outputs A, B, C. Okay, so here as I told you, I'll be explaining in deep for you after you will be learning all the concepts of SV. So don't consider about this what is this rand, what you already know about the functions. Okay, so don't consider about the rand here. Clear? Okay, so just ignore this rand. Okay, rand is for randomization purposes. In order to, as I already told you, in system verilog you will be when you are sending the input data, like for this adder you need to send the values for a and b, like 0010. So basically in verilog you have to pass the values for the test bench manually, but in case of system verilog it is not done manually, but it will be by using the technique called randomization in system verilog. Okay, this randomization consists of rand keyword. Okay, as far as it is concerned, now I am just explaining it like this only. Okay, don't worry about this, because when we enter deep into this what is randomization and all, you will be clearly understanding about this topic. So this is about transaction. So as I already told you, transaction is nothing but it consists of inputs and outputs. So nothing but a b c are the input and outputs, is it or not? Only three. So only these three will be contained within your transaction. Now what is happening? This transaction is sent from generator to driver. Is it or not? The generator is driving this transaction from generator block to driver block. So what should the generator contain? The generator should contain the transaction. Okay, along with transaction it contains many other things, but the first important thing for generator is transaction. Now what is being done here is, so the generator is driving this transaction from generator to driver, is it or not? So how is it passing? That means how the driving is done, by using the mailbox thing. Okay, you don't worry about this mailbox and all, also I'll be explaining that briefly, but I'm just giving you a basic idea. By using the mailbox, okay, by using the mailbox option called put. Okay, put means it is used to put the value, or it is used to drive the value. Okay, so by using this put method, okay, the generator is driving the transaction from generator to driver. Now what does the driver contain? Driver will obviously contain the transactions, because generator is driving the transactions. Okay, driver is taking the transactions, so it will also contain the transactions. So in generator you are putting it, so again in driver you will be getting it. Okay, the mailbox, with mailbox you will be having putting and getting options. So by using this put and get options, you will be putting the data and you will be getting the data in the driver. Okay, then from driver what will be happening? From driver the entire data is sent to the DUT, is it or not? Through interface. So what should your interface contain? Again same things. So as I already told you, interface is nothing but it is just like a bus. It is used in order to group all the input and output signals that is used in this designing. Okay, so see, ABC are the input and output signals. So all the input and output signals are grouped into one block, which is named as interface here. Clear? Yes. And from interface what is happening? It is sent to the DUT, nothing but the design under test. And again from DUT, after logic is completely applied, from this DUT what is happening? It will be sent to the monitor. Okay, basically this is the program we have written without using the monitor. So as in the starting itself I told you, you can write the test bench code by using monitor or without using monitor also. So this is the code without using monitor. You can use this, you can write the same code with using monitor also. I'll explain that some other day. Okay, so this is how the basically the thing is done. Okay, now after monitor what I told you, this entire scoreboard also, it is also optional. Like since this is just a basic program, you don't need to write about this scoreboard and monitor and all. Okay, so after this, as I told you, this entire thing like generator, driver, scoreboard, monitor, all these are encapsulated within the environment. So what does the environment contain? If you see, transaction, generator, driver. So these are the things that the environment contains. So these are the three blocks that as for now, because since you are not using monitor here, if you are using monitor also, then you should include the monitor here also. Clear? So this is about the environment. Now where is this along with, now within the environment, as I seen in the test bench architecture, you will be, this environment is again encapsulated within the test bench top. So what I told you, the test bench is nothing but test bench top. Here the test bench top consists of all the instantiations, like every instantiation, like here if you see interface and dut instantiation, if you see this is the dut instantiation. See, okay, the DUT instantiation is done, as well as the interface, the clock generation, everything, reset clock, everything is done in the test bench top. Okay, clear? So this is about the, and one more important thing is, if you see in all the blocks here, generator, driver, so if you see all these are class based. Have you seen this? The generator is also class based. See, generator, driver, transactions, everything. Transactions is also class based. Okay. But when it comes to test bench top, because it is used for DOT instantiation, it should be a module based. Okay, you should remember this. Okay, only test bench top is module based, the remaining all are class based. Okay, and then the test cases. For example, this is the adder. So here in this adder, I'm like assuming to write two test cases. Okay, one is to pass the values randomly, and the second is to pass the values like manually, like I want to give particular values to this. Okay, so I'm writing the test case. This is just like a folders. Okay, just like okay, in YouTube I'm describing playlist, like all the Verilog concepts are kept in one place, all the system Verilog concepts are kept in one place, just like you're creating different folders. Similarly, test cases also, so based on what you are going to test, they are also categorized into two types. Okay, you can write any type of test. Okay, so whatever test you are going to write, it should be in such a way that your design have to cover all these test scenarios. That means all these important points should be covered within your design. Okay, that is the first important thing you should remember. So here for this adder I am writing two test cases. One is random test. Okay, in order to randomly send the values. Okay, if you see the random test here, okay, I am not giving any values, but I am repeating the particular test case for 4 times. So by random, since I have given the rand keyword in the generate transaction and all, so by using that it will be randomly sending some values, and all the values should be passed, will be passed to this adder, and it should give the expected output, like what we are giving, what we are expecting, it should give that particular output. So this is about random test. When it comes to directed test, here if you see directed test means I am wantingly giving some values, so that comes under this direct test. Okay, so this is how the test cases will be done. Clear? So this is the basic of test bench architecture, system Verilog test bench architecture. Hope you understood about this topic. Okay, if you are still not clear, you can comment me in the comment box. I will definitely answer you. And if you are having any other doubts also, I'll be creating another video for that. Okay, because recently many of you have asked me to explain clearly about this test bench architecture for everyone. I can't message you, so that is why I'm making this video. Hope this video is helpful for you. Okay, and also if you're someone who still didn't subscribe to my channel, consider subscribing my channel and hit on the notification bell also. Also, give me a like so that it will be giving me a motivation to create more such content. Thank you.